For example, now I'm talking about the mixed flow, that is when both type of flow arrangement, that is co-current and counter current flow, exist at the same time. So for example, I will take an example of cell and tube heat exchangers, where this is the tube. Okay, so I will draw basically 4 tubes. Okay, so I have drawn, just to explain, I have drawn 4 number of tubes. This is the tube sheet. This is the tube sheet. This is the tube header, and this is the nozzle for the tube side fluid entry, and this is called as the pass partition plate. Now on the other side, okay, and this is called as the tube header. Okay, this is closed from this point. This is this shell. Okay, this is the cell. So what will happen? So I have drawn this. Okay, so what will happen? Look at this example. Tube side fluid will enter from this point, and then this pass partition will not allow the fluid to fall down, so it will only fill in the half of this section. Okay, so what you can say, the fluid will occupy this much space only. It is dry up space for time being, for time being. Okay, so what will happen? This fluid will fill in this compartment, and then it will start flowing through these 2 tubes in the positive X direction, and the cell side fluid, which is nothing but the cold fluid, will enter from this nozzle, and then it will flow in the negative X direction. Okay, so what is the direction of flow arrangement? Hot fluid which is flowing through the tubes is flowing in the X direction, and the cold fluid which is flowing through the cell side is flowing in the negative X direction, and this is flowing in the positive X direction. Cold side, the hot fluid which is flowing through the tube side, it will come at these end points, and then the liquid will fall in the tube side header. So what will happen? The liquid level will rise up in the tube header, and then what will happen? The liquid will start flowing through these tubes, okay, in the negative X direction, and then it will come at the other end, and then it will exit from the exit nozzle. So what is happening? First, the direction is positive X for the hot fluid, and then it is negative X direction, whereas cell side fluid is flowing in the negative X direction. So in the first half of the cell and tube heat exchangers, the flow arrangement is counter current, because the direction of both the fluids are opposite to each other, whereas in the bottom half of this section, the direction of both the fluids are same, negative X direction, and it is co-current flow. And that's why what you can say, in one heat exchangers you have both the type of flow arrangement, and this is called as the mixed flow. So at one point, at one place, in one heat exchangers, you have both the flow arrangement, co-current as well as the counter current. So in such situation, what you have to do, you have to use this expression for the overall rate of heat transfer, because this delta Tm expression which we have derived for co-current or counter current flow will not be applicable for the mixed flow, where you have both the type of flow. That means in one heat exchangers, if counter current as well as co-current is occurring, then you have to multiply your log mean temperature difference with temperature correction factor, which is a function of tube side and cell side number of passes and cell and tube side fluid temperature. Okay, thank you.